Hi there, this is Toby. I am preparing for a talk about time traveling debuggers in a few weeks. Um, if you're in the Atlanta area and you're interested in going to the conference where my talk will be, uh, that conference is called Refactor.tech. You can find more information on this website. Okay, so I thought I would demonstrate how what programming is like using a time traveling debugger by programming a little easy exercise on leetcode.com. It's the convert an integer to a Roman numeral problem. I have done this in the past. You might have as well. And I've been just chugging along, working through the simplest cases, and I just encountered a bug. So I thought that I would slow down and use the time traveling debugger to solve this. The time traveling debugger I'm using is PyRewind, which is a project that I worked on for a while, maybe about a year. So I'm going to use this to run the program, Roman numeral.py. And currently I'm getting this assertion error, and so let's go in with the debugger and we'll debug it. In order to invoke the debugger for PyRewind, I provide the .rewind file, which is a log file that PyRewind generates. And here, when possible, the debugger starts at the end of the program, or not when possible, when there's a runtime exception, which in this case there was because it was an assertion error. It stops at the end of the program where the assertion error occurred, and now I can actually walk backwards in time to figure out what happened. And it stepped backwards to this line, which I definitely wasn't expecting, because I was expecting it to go to line 13. I can also tell that line 13 is red, which means it has never encountered that line, which is also suspicious. So, but this jumps me to the root cause right away. It was going to the wrong branch of the program that I meant for it to go to. So mystery solved for that one. So I'm gonna reorder these branches to make the 10 one go above the 5 one. I'll rerun the program, and now all the assertions went through without errors. Okay, cool. Test something like 44. That should be like that. Uh-oh. Okay, this is a good chance to debug this. So alright, so I'll go backwards, and we are looking at the number 44. 34. Num is 34. Num was 24. Num was 14. So, so it trimmed 10 at a time. Okay. Right, so it trimmed 10 at a time is what it did, instead of trimming the 40, because you have to match exactly 40 before it will do this trimming. So if it is, so maybe what we need to do, oh, unless I could do this. Might be able to do the same trick here. Just order it after 50. Like this. That seems to have worked. And then for 90, XC, is that one? XC is 90. Okay, so I need to add, I want to put if number is greater than 90. Good. So I'm gonna try to test 99, which should give me this, I believe. That didn't work. Okay, let's use the debugger. Okay, so we're here, we're gonna walk backwards. And it says 99 is the number. I'm gonna walk backwards. And this is I times num, where num is -1. What? Why is num -1? I'm gonna consult our timeline. Okay, so actually the execution of this call isn't super complicated. It was like 20 lines or something. When it hit this, if the num is greater or equal to 90, then it hit this clause, and then it did into Roman num minus 100 here. And again here, I guess the num is -1. Yes, the reason the num is -1 is because we had 99 minus 100. Yeah, that's the problem. 99 minus 100 is -1, and that shouldn't happen. So we should be subtracting 90 here instead. And that works. Okay. I think at this point I just need to add the clauses for 500 or 400 and 900, and then we're probably done. To paste in my solution. Plug it in. Run it. Okay, submit it. Yay, accepted. Cool. So the solution, I like this solution. It's very simple. I mean, I could have made it smarter in a sense by doing digit by digit, but this is simple enough, I think, that it doesn't warrant that. We did get a few debugging sessions in there, so I'm happy about that.